The rules aren't changing from yesterday. Just what you need might be a little tougher to find today. Okay, I'm not changing the rules. Right off the bat, how do I know I have to do this one indirectly, other than it says indirect proofs day 2 at the top of your page? How do I know I'm on a test? I'm on the midterm in January. I'm on the Regents in June. How am I going to know a proofs needs to be done indirectly? Logan, go. Correct. Look at the proof statement right there. That says, hey, I better do this indirectly. All right, so here we go. Let's set up statements reasons. I'm only going to do 2 of these with you today. The rest are on your own. Need some time for you guys to work and for me to roam around to judge where you're at. Whoop. So go ahead, get your givens in. Triangle ABC is, ooh, that's an interesting given, huh? Is scalene. What's scalene again? No sides equal. That's interesting that they gave us that. AE and CD are altitudes. I'm hoping at this point in the unit, you guys know what an altitude is and can mark your diagram appropriately. Because this is an indirect proof, we got to start it off with our assumption, right? I'm not changing the rules today. What is our assumption based on this proof? What are we going to assume is true and go from? Let's go. Start it off. 22. What are we going to assume is true there, Dylan? The opposite of the proof statement. AE is congruent to CD. That's our assumption. And we can use the assumption as a given. Use it, use it. Here's where it gets a little tricky right today. How many givens did I provide you? What's up, Logan? Great. I'm devastated. Now I feel like I can teach now. Thank you. That I know his whereabouts. Thank you. All right. How many givens did I provide? 2. You know, in every indirect proof, you have to contradict one of them. And usually, like last night, look, last night it was pretty easy. You're just like, oh, I'm just going to contradict the not equal one. Easy. I don't have that, though, here. I don't have a not equal. But I still got to contradict one of the 2. So either can I contradict that ABC is scalene, or can I contradict that these are altitudes? Thoughts on which one do you think it's going to be? Because you're picking one over the other. This isn't like, I feel like going this way. No. You're going to do one over the other. Yes, Matthew? Good choice. Scalene. My question in return would be to everyone, how do you contradict the triangle scalene? What's scalene again? No sides. So how do you contradict that? Prove 2 sides. Show it's what instead of scalene? All right, we got a plan. We got a plan down now. Show triangle ABC is isosceles. That would contradict its scalene. Okay? Good there. All right, so go ahead, start marking your diagram up, and we'll get talking, because saying that it's going to be isosceles is a lot different than showing it's going to be isosceles. Trust me. Where are we going here? The quiz or the test? Okay, that's all on graphing. Yep, that's fine. Yep, right up front. All right, so how do you show something's isosceles? Remind me again. How do I show something's isosceles? 2 sides or? Okay, whatever goes. 2 sides or 2 angles in that triangle need to be congruent. All right, so what do altitudes form? Right angles. So CAE is an altitude, so it looks like I have a right angle on both sides there. CD is an altitude, so it looks like I have a right angle on both sides there. And also, remember, your assumption said what? AE and CD are congruent. I don't want to mark that. You can somehow, but it's going to just be messy on my diagram. All right. We've done a lot of this before. So you're telling me I got to get 2 sides or 2 angles congruent. And usually the only way I do that is prove a pair of triangles congruent. Yes? That's the only way I usually get sides or angles congruent, is by saying CPCTC after the triangles are congruent. Can anybody find any triangles up here that maybe I could possibly find congruent. Cece, start us off. Yeah, I like those overlapping ones right there that she gave me. Ready? She's saying DAC, and I think she picked that triangle because she already has a right angle, and we know DC and AE from our assumption are congruent. So good call. Good call. That's not really doing anything, but hey. All right, so we have the right angles and we have the assumption sides. Can anybody see any other sides or angles that I could put up here? Naomi, what's up? Yep, AC is reflexive. And I know we're talking about all this, but we got to make sure we put it in the proof here in a minute. Wait a second. We have what? Two sides and an angle, right? Everyone agree? We have two. I know I didn't mark, but remember, DC and AE are congruent by the assumption. We have two sides and an angle, right? I believe the only method I know is side angle side with two sides and an angle. I don't think that right angle's in between. Everyone agree with me? See the right angle? Here are the two sides. Is that right angle in between? That's not working. Can't use side angle side. What type of triangles are they? And if the angle's not in the middle of a right triangle, we have a special one, don't we? A fifth and final method, which says HL. Where's the H? What side's the H for both triangles? The reflexive side, and the legs are the assumption side. So yes, this is going to be an HL proof. Ready to go now. Woo! Nasty. Here we go. That's why you're here taking honors. All right, what do I still need to put in the proof? I got a ton to put in. We just talked for 2 minutes about why these triangles are congruent. I've yet to write anything in. What's got to go in? 16, what's got to go in? AC congruent to itself. All right, got that in. I still have markings on my diagram, though, that are yet to be in my proof. What other markings that need to go in there? Let's go 11. Yep. Angle ADC and angle ADC CEA are right angles. What are you guys going to put for a reason for that one? Altitudes form right angles, definition of an altitude. Okay. You could, in step 5, say they're congruent. That's fine, but it is an HL proof, so it's not needed, remember. All right, in an HL proof, you don't need to tell me the right angles are congruent, but if you do, no big deal. All right, just an extra step. But you do need what in an HL proof before I say they're congruent by HL? Anybody remember that? Going digging deep. What's up, Naomi? You gotta tell me the right triangles. Yep. So triangle ADC and triangle, what do I got there? I don't care about the order in this one anyway. CEA are right triangles. What's your reason going to be? HL? HL? Why don't we just put vertical angles are congruent over there? Right triangles have right angles, HL. Now you can say they're congruent by HL. This one's a beast. I love it. ADC, if I go ADC, what do I got there, kids? I got to go CEA. All right. So they're congruent. Great. Where's that lead me to that they're congruent? Remember, I need to show their isosceles event. That's triangles isosceles. These two triangles being congruent leads me to what now? I get it, CPCTC, but what's CPCTC going to prove? Which angles? DAC, this full angle in my yellow one, and ECA, this full angle in my gray one. Got it. Angle DAC congruent to ECA. Why did I put a... come on. CPCTC. All right, now what type of triangle is ABC? It's isosceles. I know you guys love to prove sides congruent, but it was the angles here. Why is it isosceles? Oh, good reason why. Yeah. 17, why is this beast isosceles? They are? What did we just prove last step? Sides? In a triangle, two angles congruent imply isosceles triangle. Guys, what do you have in a minute, or maybe now, what do you have written on your paper? I know ABC's isosceles. I know you have that written, but what is that? That contradicts the given, doesn't it? All right, so once I have a contradiction, we can say our assumption is false, meaning the opposite of it must be true. AE is not equal to CD. Nope, that's, yes. Assumption led to contradiction. And remember what else you got to provide to me. Where is that contradiction? It's not the assumption you all right? The assumption led to a contradiction. Where is it? ABC is scalene in step 1, and ABC is isosceles in step 8. Woo! HL in an indirect proof. Doesn't get any better. Does not get any better. A little bit tougher today. Any questions from you guys there? Need a breath. Another stretch out before we get to the next one. That was pretty hardcore. Anything? That was fun, wasn't it? Yeah, it was fun. That was fun. The old fade right there. By the way, first period had 2 opportunities at no homework. Couldn't get it. They even accused me, because they're so bad at guessing the next slide. They might be the worst in the nation. Accused me of downloading new slides over Thanksgiving break. I've never seen that one before. Page curl. Never seen that one before. Okay, get it. All right, whatever. You're just awful at it. I don't know what to tell you. Have you guys gotten one yet? Okay, there you go. Okay. Ready? Here we go. Never seen page curl in 14 weeks of school. And the second one was a shatter. I never seen that one before. All right, another tough one here. Rules don't change. What's going to be your assumption in this one? What are we going to assume is true? 24. Great job. 6. Here we go. What's our assumption? 6. Yes, it is. How many givens did I provide you? 2. So you know you're going to contradict one of them. Which one? Which one? I feel like you know which one it is, but you don't want to say it because you're like, that doesn't seem right. It's too tough. But that's the one we're going to contradict. Come on. How are you going to contradict that? If you were to pick that one, which, okay, how are you going to contradict that? By saying it's not equal, right? That's the only way you can contradict it. And then aren't we doing like an indirect proof within an indirect proof, which I don't think we want to go down, right? So probably the other one, right? AD does not bisect CAB. So how would we contradict that? By saying, how would we contradict this statement? AD does bisect. So how can we prove that? AD does bisect angle CAB. Because if we can do that, that's a contradiction. How can we do that, though? How can we show that AD does cut CAB in half? By doing what? Jacob, go ahead. Whoa, 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 whoa. Even before that, you're getting too far ahead of me. If I gave you that, what would you tell me in return? What 2 angles would be congruent? There you go. Hey, guys, if you can get me these 2 right here, if you can get me those 2 congruent, does an AD bisect it? Okay. Get them congruent. How can I get them congruent? Now, usually, how do I get 2 angles congruent? By proving the triangles. All right, so just they don't overlap here, but I'll still highlight them. So to get those angles, I'm going to need this triangle congruent to this one. And I'll tell you, kids don't like this proof because of the way the triangles are positioned. You like them right next to each other. All right, you like these 2. You don't like these 2 the way they look. Sorry, prove them congruent. All right, let's see what we have. 1 was congruent to 2. Ooh, how can I use that to my advantage? AB, oh, and your assumption was what? What was our assumption? Okay, so, oh, hey, you got a pair of sides by your assumption. You got a pair of sides. And you better use 1 congruent to 2 because it was a given. You better use it. Okay, where else can I get sides or angles in those 2 triangles? Come on, dig deep. Where else can I get sides or angles in these 2 here, the red and the yellow? 12. Don't say why. He's correct. Look, why is BD going to be congruent to DC? Ooh, where do you get that from? Because that is correct. BD congruent to DC, 100% correct, but why? Why are those 2 sides in particular congruent to each other? A little old theorem here we used back in Unit 4, I believe. 18, any idea? Okay, I gave you 1 and 2, correct? Aren't the angles 1 and 2 in triangle BDC? What type of triangle is BDC then? And we have a theorem that says if the angles are congruent, so are across. Everyone see that? In a triangle, congruent sides are where? Across from congruent angles. Way to go, kids. Way to go. You got 2 sides. You need 1 more to prove them congruent. You need 1 more something. 1 more something to prove them congruent. Where's it going to be? Oh boy, there's actually two ways you could go here. Two ways, an easy way and a couple more steps way. I'll hear both. One. You got the shared side. Was anybody go a different way? Because there is a different way to do it. Supplements. Okay. Yes, you could do subtraction of angles to get these two here, but I'll just go with AD congruent to itself. Nice. Now I know the triangles are congruent by what method? Side, side, side. So triangle, what is it, ABD. Triangle ABD is congruent to, if I go ABD, come on, ABD. Calm down. Why were we proving those triangles to begin with? What was the purpose of proving those triangles congruent? To get angles BAD and CAD congruent. That is not my contradiction, though. That's not contradicted anything. Right? Everyone agree? You don't have a contradiction written down anywhere in your proof yet. But knowing those two angles are congruent, that makes AD what? AD now is bisecting angle CAB. There's your contradiction. Now the question is why does it bisect? Definition of a bisector, not going to fly. You tell me. How do you know it's a bisector? What's up, Michael? That's not bad. I'd probably take that. I'd take that, yeah. Now what? Say that again. Okay, stop right there. Name those two adjacent angles that are congruent. Okay, that's all I need here. Again, you want to put that, Mike, I'm good with it. I like it a lot. But you can just tell me the angles, those two adjacent angles are already congruent. And then we have a contradiction, don't we? Do we have a contradiction? Yeah. So what can we say about the old assumption? It was false, meaning AB is definitely not congruent to CA. Assumption led to, and I don't think I told this story yesterday in here, a couple years ago. Altac, did I tell it? All right, yeah, don't use it. Never mind. Whoa, whoa, whoa. Where's that contradiction? The given and 7. All right, we really need some time these last 15 minutes here to get some stuff done on your own. Can I give you a quick hint for number 3? Out of the two givens, which one are you going to contradict? You're going to try to get MA equal to AT, right? I'll just give you a quick hint so you don't get frustrated. You will not be proving triangles congruent in this one. You'll be finding MA congruent to AT a different way. All right? If you get stuck, let me know. You're on your own now, guys, on your own. If you want me to look over anything, let me know. If you get stuck and you need a little push, let me know. Not a big deal. But I can tell you on number 3, you will not be proving any triangles congruent.